Hello everyone, today we will solve a heat transfer problem. So we will see the temperature profile along the x-axis. Suppose we have 2 point here and temperature of 2 point is given 10 degrees centigrade and 20 degrees centigrade, and if it is 1 meter apart, so what will be the temperature profile along the axis? We will do it in console. We will use two methods to solve this problem. So one, we will use the PDE equation, or another we will use the predefined heat transfer in solid. Let's open the console, click on model wizard 1D, and first we will use partial differential equation to solve this problem. So click on mathematics, go to the partial differential equation, and we will use the coefficient form PDE. Just add it into model wizard and go for study. We will choose the stationary and done. So first we have to draw the geometry. Right click on it, click on interval, and we will define two coordinates. It's based on coordinates. You can choose the interval length also. So 0 and 1 will selected. So this one is our geometry. Now come to the PDE. Here the first I will show you the equation for this. So here equation is given in du in this form. To solve this problem, we use the basic equation of this, but in console you will get this equation as a PDE form. So we have to convert this equation into this form, and then we will solve this. Here also the thermal conductivity varies with the temperature which is given here. So to convert this equation into this form, we have to nullify all the parts, and we have to keep only the temperature as a function of x. So the part which is showing the temperature as a function of x is this part. So we have to keep this one, and rest of parts will be the 0. To convert it into 0, we will put the coefficient value 0. So EA, DA, alpha, gamma, beta, A, F all will be the 0, and we will put the value of C in the form of 1 minus T. So we will get the K value as 1 plus C. Okay, here we are. First we will see the equation. Here independent variable is U. To change this in T, we can change it. First click on this one and dependent variable. Here our dependent variable is the temperature. We will change it to T. Now come back to the equation. So it has changed to correct form which we want. So here the C value we will change it to minus 1 plus T, because our C represent the thermal conductivity, so which varies with the temperature. Rest of coefficient we will convert into 0. So we will change it to 0. Now this equation has converted into which we want. Next thing, we have set up this thing. Next thing we have to do is the put the boundary condition. So we will select the boundary condition, and we will select this point, and the value of temperature is 10. We will right click on it, and we will select again. This will show the boundary condition 2, and we will put it as 20. You can see that the temperature It's not r which we think is the radius, it's equal to the temperature. You can see here. We will move it to the mesh. We will build select, go to the study and compute it. As we can see here, we will get the temperature as a function of x. Temperature start from 10, it goes to 20 along with the x-axis. Same problem we will solve using mathematical model wizard. So in method 2 we will open the model wizard, everything will be same. 1D, here we will choose predefined physics. It will be in heat transfer in solid. We will add it, study, and here we will choose stationary and turn. So for geometry again we will build the same thing. Like previous one, we do not have to change anything. We only change here is the thermal conductivity, and we will write here thermal conductivity 1 plus capital T, and rest of things will be as it is. Only thing we have to add is boundary condition, and let's add the temperature as a boundary condition. Here this we will keep 10, and boundary condition 2 this one, and we will keep it 20, and we will generate the mesh. We will study. If we want to plot thermal conductivity or heat flux, so we can do also. We will go to temperature and we will plot a line graph here. Just go to the expression heat transfer in solid. Suppose we want to see heat flux, conductive heat flux in x component. We will add it. We will select the geometry, and if we click on plot, okay, let me disable this one. Okay, so we can see here the how conductive heat flux is varying along with the x-axis. So like this we have solved the heat transfer. Thank you. If you like this, please like and subscribe.